Hey, it's Mr. Allred, and here we are. We've finally gotten to the point where we're going to graph our first quadratic and admit that we're doing it. And the most basic quadratic that there is y equals x squared, or f of x equals x squared. And if we understand what the basic function looks like, then we can look at the characteristics of how we can change that to graph similar equations. So when we looked at y equals mx plus b, we understood that as the general form of a line, and we were able to transfer it over to make any line we want. So let's just kind of talk about this f of x equals x squared, or y equals x squared. Either way, we did something similar a little bit ago, but let's first of all just kind of do some points. Okay. So if you've never graphed a function before, you don't know which points are going to be your best ones to kind of show you what it looks like, but I'm going to use the same set that I used before. So we're going to plug these numbers into x squared and see what we get out, and then we're going to plot them. So we plug -2 in and we get 4. So over on my graph, -2, 4, because we're making a point every time we have an x, f of x, or x, y combination. -1 squared is 1. 0 squared is 0. You may feel like that looks somewhat like a line, but see what happens here in a moment. 1 squared is 1. So the idea of the line has fallen apart. And 2 squared is 4. So I can't say that we have enough points to prove to you that this is going to be the graph. But if you wanted to put some more points in and plot them, you could. But in general, if we just take the points we have and connect them, we get this U-shaped item. We call that a parabola. The U-shaped quadratic. And what we're going to see is we're going to use this U-shape in a variety of ways. We can take that U-shape, it may be open up like a U. It may be open down like a U as we go into variations of the quadratic. And we can take that U, if you imagine it just being laying on top of a graph or on top of the table, and move it around. So if we left the XY grid in place, we might have a U that ends up here depending on our function, or maybe a U that ends up down here if we have a different function. But that U shape is going to come out of these quadratic functions. Okay. Let me take those off so they don't confuse anybody later on. Alright, so let's do something more specific. And my little face is in the way, so let's see if I can move it over. Just enough to get the C in. Alright, so here we're going to graph the quadratic. And this is the way they should be written. ax squared plus bx plus c. This is the way we wrote them when we solved the equations. It's the way we wrote them when we factored them. So now that they're functions and we're going to graph them, the same thing. So instead of going down the road of plotting a bunch of points, because we don't know where this U shape might be, and we might get some really weird stuff if we always do from -2 to +2, let's do this a little bit more strategically. Let's find the y-intercepts. Okay, and the function that I'm going to work with here is f of x equals x squared plus 6x plus 5. And if I want the x-intercepts, remember if I want the y-intercepts, I want to let x equal 0. So in that case, basically what I've got is 0 squared plus 6 times 0 plus 5 equals the 5. Because of all those zeros going away. So the y-intercept is the point 0, 5. So let's kind of highlight that. And then let's come over here on the graph and plot it. So my y-intercept is 0, 5. So I guaranteed that I was getting a point somewhere close to the origin of this graph. At least if I have an XY grid, I know I can put it somewhere. So after finding the y-intercept, let's see if we can also find the x-intercept. So remember, with the x-intercept, if you go back to how I find intercepts, we're going to let y or f of x equals 0. Okay, and then we're going to solve for x. So we'll have 0 equals x squared plus 6x plus 5. We can factor that right-hand side, so x plus 1 times x plus 5. So that's all equal to 0. We can make two small equations. X plus 1 equals 0. X plus 5 equals 0. We get x equals -1. X equals -5. That's the point -1, 0. And also the point -5, 0. So quadratic sometimes had two solutions. This one also has two solutions, which means it has two x-intercepts. Okay, so let's see if we can plot those. -1, 0, and -5, 0. So this may look hard pressed at first for you to imagine how that U-shape is going to happen, but I'll put this on here just for now. What's going to happen is we have these two x-intercepts and we've got to connect to the y-intercept. So basically we're going to have something that looks like this going through those points. That U is going to be open upward. But the question is, how far down does that U shape go? How low is that valley? So as an explanation here, let me take off the actual, there we go, and kind of discuss. So we got these two x-intercepts in this particular one, -1 and -5. And U is symmetric. So if I come halfway between there, halfway between -1 and -5 would be at -3. So x equals -3 is kind of like the middle of this U shape. That's going to be called the vertex. Okay, we're going to work with that. But we also need a y value to go with it. So basically that means we're looking for f of -3. So we might know where the middle is, but that middle could go down 1, it could go down 10. We don't know just how deep it is. So halfway between those two x-intercepts, because we're making a symmetric graph, a U-shape, will be where the middle of the graph is. So if you're thinking about like a horseshoe or the U-shape, it will be in the center. If it's open up, it will look like that. If it's open down, it will look like this. But the parabola has symmetry. So plugging the -3 into our function, we would get -3 squared plus 6 times -3 plus 5. So that y would be 9, 14 minus 18 minus 4. So that vertex point will be -3, -4. Way down here. And there I have enough information to connect one side of the U shape. Sorry, I'm trying to write a little awkwardly here. My eraser didn't pick up. Try again. There we go. Okay, let's try again. Trying to connect this U shape over here where I have the most points, and then I'm going to mirror it on the other side to go through the points that I have. So I've found two characteristics that I can find for any quadratic or any function, the y-intercept and the x-intercept. And then we found this other characteristic that we're going to call the vertex that is fairly unique to quadratics. Okay, and that gave me enough information to graph it all together. Okay, so let's kind of put this together in some steps. Okay, well, first of all, the vertex. So the vertex, we said the vertex was the middle of that U-shaped parabola, and it will either be the highest point if the parabola is open down, or the lowest point if it's open up. So it's either the max or min of the graph. And we haven't seen this part because we haven't done it. let's go ahead and kind of show you where this vertex formula down here comes from. Okay, I've got a formula for the vertex, so let's create that. So going back to x squared plus 6x plus 5. We set that equal to 0 for our x-intercepts and solved it by factoring. But we also know that we can't factor every quadratic. So if we think back to how that comes about, we could also find x-intercepts using the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, if you notice this plus or minus in here, basically we're taking the negative b over 2a and keeping it consistent. Okay, that is actually the vertex coordinate. And then if that is the middle, we can verify that because we're adding this square root to it to kind of move off that middle to the right. We're subtracting the same amount to move off that center point to the left to get the 2x intercepts. So we can find that vertex using this negative b over 2a formula. And in that case, we can plug that negative b over 2a into the function to get the y. So kind of use this formula as the standard. The x coordinate of the vertex is negative b over 2a. Instead of trying to always look for 2x intercepts and the midpoint of them, because we're going to see some parabolas that don't have x intercepts. And that could be because they're all above the x-axis or all below. Okay. So we're going to stop there, but kind of keep that information handy.